Okay, so in 4.8, we're going to be talking about dividing polynomials, and we're going to be doing this with long division on part of it. So these first two problems, we're not using long division, but because I want you to notice that we are dividing by a monomial here. All right, so up here, to divide a polynomial by a monomial, divide every term in the polynomial by the monomial, okay, and then write it in lowest terms. So meaning on this one, I would rewrite this as 15x squared divided by 3 minus 12x divided by 3 and then plus 6 divided by 3. So we're taking whatever is in the denominator when it's a monomial and just dividing each of the parts by that. Okay, now look down here. I just want to look ahead just to make sure you see. This is a monomial because it's connected by multiplication. All right. This is a trinomial because we have it connected, three terms connected by add or subtract. So just kind of make sure that you're paying attention to those things. Okay, but to do this, we are just going to be dividing each part here. So 3 divides into 15 5 times, and so then we're left with just 5x squared. Here, 3 divides into 12 4 times. So in that term, we're left with negative 4x, and 3 divides into 6 twice, and so we're left with plus 2. And that is it on that one. That's all you have to do. Okay? So the next one, like I said, is going to be pretty similar to it. Let's set this up so that we have each term being divided by that monomial. So 8x y squared over x squared y squared. Right, so I'm just going to do each of these terms divided by x squared y squared. All right, and then on this we'll have to use kind of some properties of exponents when we're simplifying the variables in this. And so make sure you're kind of thinking back, right, how to do that. So on this first term, again, when we're looking at this, we can see, all right, there's nothing on the bottom to divide the coefficient by, but we've got 2 x's on the bottom and 1 on the top. So remember, that leaves 1 x on the bottom, because when we talked about doing those properties of exponents, wherever there were more x's, right, that's where it's going to end up. And on this one, y squared divided by y squared is just 1, so that's gone. So my first term that's left there is just 8 over x. All right, let's look at the next term on this. So here are x squareds, divide out, and this time we have a y to the first on the top and a y to the second on the bottom, so we're left with just a y on the bottom. So minus 9 over y is all that's left when we simplify that. And then on the last one, you can see that our x squareds and our y squareds both divide out, right? And remember, when I'm dividing those out, I'm making ones. All right, y squared divided by y squared is 1. And so then I'm really doing like 6 times 1 times 1, which is just 6. And so that would be your simplified answer, and that's how you'd leave it. So any questions on these first two where we're dividing by monomials?
Nope.
All right. Well, let's go take a look at long division. So it's probably been a while since you've done long division, because I don't know about you, but when I have to divide something that looks like this, I usually just pull out my calculator to do it, right? But in order to divide polynomials, you need to remember the steps that you take in long division. And so we're going to start off just just with a little review of how to do this long division. All right, so setting it up, when we're dividing, the number that we're dividing by is called the divisor, and the number that we're dividing into is called the dividend. So the divisor, 26, goes on the outside, and we're dividing into 34,927. Okay, so kind of, keep in mind here, we're going to take in 36 and just look at our first two digits here, that 34. And we're just going to think to ourselves, how many times can 26 divide into 34? And that's just going to be one time. So we'll put it up there and then we say 1 times 26 is 26. All right. And then does anybody remember what we do at this point when we were doing this long division?
Subtract 34 and 26?
Yeah. Yeah, so we're going to subtract those, right? 34 minus 26, and we get 8. Let's see, and I'm going to put this subtract in red because I want to make sure it stands out pretty good here. And we're left with 8. Okay, and then the next thing that we do is we bring down that next number. Don't bring down all of the digits. I've seen students try and do that, and it just makes it really confusing. So just bring it down one number at a time. So when we bring this 9 down, right, we have 89 now, and then we start the process over again. So how many times will 26 divide into 89?
3 times?
Yeah, 3 times. And then we figure out what's 3 times 26.
75?
Or that would be if it was 25, so 78, I think, right, because it's by 26.
Oops.
That's okay. Like, it's easy to do that. All right, and then again, like I said, we're going to subtract, okay, and then what are we left with here? Looks like 11, right, and then bring down the next number. So now we got to figure out how many times will 26 divide into 112. I think it goes in 4 times. Yeah, what is 4 times 26?
104.
Yeah, so let's put that underneath here. And then we'll subtract again, right? So this whole algorithm that we're doing here is going to be really similar to what we need to understand. Okay, we're left with 8 here when we subtract those, and then bring down our last number, which is 7. And then start it again. How many times will 26 go into 87? I think it goes 3 times because we determined that 3 times 26 before was 78. So, and then let's subtract that. And what do we get there when we subtract those?
9?
Yeah. And so 9 is our remainder. Right? So sometimes we write this as like, so 1,343, and then we say like remainder 9. Right? However, for what we're going to be doing, we're going to want to write it just a little bit differently. And we write it like this sometimes when we're doing long division with just numbers, where we have the 1,343, and then you do 9, so whatever the remainder is, over our divisor, which was 26. And so our answers are going to be looking more, something more like this when we're doing the long division with polynomials. Okay? So hopefully that was a good refresher on how to do that, because I know, like I said, people rarely do long division anymore, but you've got to know how to do it for the polynomials. All right, so let's see how this kind of applies to what we're going to be doing on this first problem. So again, what we're dividing by, our divisor is m minus 2, so that's going to go on the outside. Actually, let me move this and make sure I have more room. I'm going to put it over here. So let's see, so m minus 2, and then we're dividing into the 2m squared plus m minus 10. Now, a couple of things you need to look for when we are setting this up is that we need to make sure both the divisor and the dividend are in descending order. So that means that we, have our highest exponent and then our next highest exponent and so on. So we've got to make sure it's in that order. And sometimes there might be some missing terms, right? Say that there was no m term on this one. If there was nothing there that had an m next to it, then we would have to put a 0 in to hold the place. And we'll do one of those here in a little bit, but I just wanted to warn you, we kind of need to look at those things as we're setting them up. Okay, so when we're doing this division, and please make sure, ask questions when you have them, because this, I know, can be a little bit confusing, and especially because especially on Zoom, it's a little bit harder to show you what I'm trying to show you, but hopefully we can make this work. So we're going to just look at our first terms of each of these polynomials, right? So just the m and just the 2m squared, right? That's what we're focusing on. Don't worry about the other stuff right now. So what we're going to ask ourselves is we're going to say, what times m gives me 2m squared? So if I said, 2m, so let's think about this, right? 2m times m gives me that 2m squared. So I'm trying to get that to match, right? And then this next part is the part that is usually forgotten about. You can't just do it by just that one term. We've got two terms out here. So I also need to multiply that 2m by the negative 2. So it's kind of like I'm distributing it. I'm multiplying it by the m, and I'm also multiplying it by the negative 2. All right, so 2m times negative 2 is negative 4m, and then I put it underneath that m term there. Okay, so let me pause right there. You guys good to that point? See what I'm doing? Okay, so now this would be the point in which we were trying to do some subtraction before, right? But we're subtracting two terms this time. It's not just one term. And so we got to be really careful on this. So instead of just thinking subtraction on this, I want you to think change signs. So meaning, so of what we just found here. So this is a positive 2m squared. So if I'm trying to subtract, that's going to make that a negative 2m squared. But I can't forget about this guy too. If I subtract a negative 4m, that gives me positive 4m. So basically, I'm changing the signs of both of those terms before I do my, combining these together. So what happens here is we see, all right, when we do that, the 2m squareds are gone. And that's what we were trying to make happen. So that's good that that happened. And then we're left with, right, m plus 4m, which is going to be 5m. So I'm combining those together after I change the signs, how that is. And then just like we did on the long division problem above, we bring down, and on this one we'll bring down the next term. Okay, and then we start this process over again. So now we're going to say, what times m gives me 5m? So remember, you're not thinking about that negative 2 or that negative 10 right now. Okay, what times m gives me 5m? 5. And since it's a positive 5, we need to put plus 5 here. All right, and then again, we're going to distribute that through. Right? We're going to multiply 5 by both of these. So 5 times m is 5m. 5 times negative 2 is negative 10. And then we need to change signs. So make this subtract, make this add. And when we do that, we see, oh, we're left with a remainder of 0. All right, so we won't have to, do anything else with it except just leave our answer. Our answer would be 2m plus 5 because there's no remainder. We don't need to do that. However, if it gives you on the homework a place for the quotient, so the quotient means like the answer to a division question, so that's this 2m plus 5, and then they also give you a blank for the remainder, and if our remainder is 0, make sure you put a 0 in there, because if you leave it blank, it just thinks that you just didn't put it in. It doesn't know that you are meaning it to be 0, so make sure you put that in. Okay, so sometimes some of the homework problems will have this, and so make sure you do that. Okay, what can I clarify for you on this problem 3?
I'm good. I'm just wanting to see the remainder one.
Yeah, I know. Okay, so let's go on to this next one here, right? So this one is a little bit different. Remember I said, okay, when we set this up, all right, we got to make sure that we know what's outside and inside. So the outside stuff is going to be this 3r squared minus 2. However, do you see that there is a missing r term in there? If I was trying to write a polynomial with, all of the terms there, I'm missing that r. So I really want to write this as 3r squared plus 0r, and I'll show you why this makes a difference when we're doing this, and then minus 2. So that's what we need to put out here. Include that 0 out there. So I'm going to have 3r squared plus 0r minus 2. And then on the inside, we're going to have all of this stuff. Now double check, are there any terms that are missing on this? I want to make sure you guys understand what I mean by that. Do you think there's any terms missing on that top part?
4, 3, 2, no. Oops.
Yeah, it has all of them, right? I'm glad you counted that up, right? So it starts with the power of 4, power of 3, power of 2, and then there will be a power of 1 there. It's kind of like an invisible 1, and then our constant term. So we don't need to put any zeros on this on the inside. Let's just write this down like it is. So 6r to the 4th plus 9r cubed plus 2r squared minus 8r and then plus 7. Okay, so again, starting this out, you're just looking at the first terms of each of them. All right, so just kind of, don't think about the other stuff quite yet. So if we're looking at these two terms that I underlined, we're thinking, what times 3r squared gives me 6r to the 4th?
2r squared?
Yeah, 2r squared. Does everybody see that? And usually we write this so that these are like the r squareds are above each other and stuff. It doesn't matter. If you don't want to, I just do it this way out of habit, but you don't have to. All right, so if we take 2r squared and we multiply it by 3r squared, right, we get that 6r to the 4th, which is what we were looking for. Because remember, with our properties of exponents, r squared times r squared, we add those exponents together. That's why we have r to the 4th. Okay, now we've got to multiply it by the next term. So anything times 0 is just 0. So I'll have plus 0, and then r times r squared is r to the 3rd. All right, and then let's do the last one there. multiply that by -2, and that's going to give me -4r squared. So do you see, if we didn't put that 0 in there, we wouldn't have our like terms lined up, right? We'd end up having that like 4r squared under our 9r cubed. And we want to have these lined up because that's how we add and subtract polynomials. We have to have like terms with those. Okay, so got that here. What's our next step?
Change the sign.
Yeah, change the signs, all right? So we're going to make that a subtract. With, with 0, it doesn't matter. 0 doesn't really carry a sign, but if you want to change it just to keep it consistent, you can do that. And then when we combine those together, all right, we got that 6r to the 4th is gone, which is what we were trying to make happen, all right? But now when we combine these together, we get 9r to the 3rd. And we combine these together, we get plus 6r squared. Okay. Okay. Anything there now that you have questions on?
No.
Okay, make sure you speak up if you do, because sometimes it's just hard to figure out, like, where did you get that from? Okay, so I'm going to get rid of those lines, just to make sure it's not confusing on this next part. Okay, so now let's try this again, right? We're starting it again. What times 3r gives me 9r cubed?
Mm, 3r?
Yeah, 3r, right? Because 3 times 3 is the 9, and then r times r squared is r cubed. Right, so that's why it needs to be that. So again now, right, distribute that to all 3 parts. So I've got, oh, whoops, I forgot to do something, guys. What did I forget to do? Got to bring down that next part, right? I would have remembered when I got to this because I'm multiplying that 3r by 3 terms. So I need to have 3 terms here to put my numbers underneath. Okay, so 3r times 3r squared is 9r cubed. 3r times 0r is going to be 0r squared. And then 3r times -2 is going to be -6r. Right, and now, that's the subtract part. Remember, you're changing the signs. And then combining together what you can here. So we get 6r squared, and then -8 plus 6 is going to give us -2r there, and then bring down the last term, plus 7. Right, that kind of looks like a b instead of a 6. Let me try and make that look more like a 6. Okay, let's try this again now, right? So what times 3r squared gives me 6r squared?
So 2.
2, just 2, right? So plus 2. Yes. And now we'll distribute that through to all 3 of these terms here. 2 times 3r squared is 6r squared. 2 times 0r is going to be plus 0r. And then 2 times -2 is -4. Right? And then at this point, we see that we need to change signs, and that first term is gone, which is what we were trying to have happen, so that's awesome. And we're left with -2r plus 11. All right, now there's nothing more to bring down, so this is our remainder. All right, that's going to be our remainder. And this other part is what's called our quotient. So when I'm writing the answer down, it needs to be in the form of quotient plus remainder over the divisor. So when I write this down for my answer, I'm going to have my 2r squared plus 3r plus 2. And then I need to have like an add or subtract sign there. I encourage you just to do the add sign and then keep the negative in the fraction part. So let's put plus, and then in my fraction, remember my remainder has to go on top. So I'm going to have negative 2r plus 11. And then my divisor, let's just go back to this. We don't have to have that 0r in it. We did that just to make it match up nicely when we were working it through. So let's put on the bottom here 3r squared minus 2. Okay. And that would be how you'll want to have your answer. So a lot of them will say to write it this way, in the quotient plus remainder over divisor form. All right, anything I can clarify for you better there?
No.
Okay, and this is just going to take some practice, right? You can see, like, especially if you're feeling kind of rusty on long division stuff, it's just going to take a little bit of practice to get used to that algorithm again, right? The way that you do it. So, okay, so let's do one more here on this part, and let's get it set up. All right, so my m minus 3 is on the outside. And then tell me what I'm going to have inside. Somebody tell me.
3x cubed plus 0x squared minus 2x plus 5.
Awesome, right? So you notice that there was a missing term, and you went ahead and put that 0 in to hold that place open for it. Right? So make sure you remember to do that, right? We needed a 0x squared there. Okay, so let's try this again, right, and see how you can do on this one. Looking at our first terms of each of these polynomials, what times m gives me 3m cubed? Whoops, why do I have an x and m? I don't know what happened there. Let's change this one to an x. Can't really do this when we have different variables. Sorry, I didn't notice that it was like that. Okay, let's change that to an x minus 3. Sorry about that. Okay, this looks better now. All right, so what times x gives me 3x cubed?
3x squared.
Okay, so let's put our 3x squared up here in our answer part. All right, 3x squared times x gives me 3x to the third. And then make sure you multiply it by the other one as well. 3x squared times negative 3 is negative 9x squared. All right, so now we'll change signs and get rid of that first term. And when we add these together, we get 9x squared. And then let's bring down our next term. Okay, so I'll try it again. What times x gives me 9x squared? It's going to be 9x, right? 9x times another x is going to give me 9x squared. And then 9x times negative 3 gives me negative 27x. All right, so now let's change our signs again. That first term's gone, and here we're left with 25x, and then we need to bring down our 5. So bring down that plus 5. And then let's do this again. What times x gives me 25x? Well, that's going to be 25. So 25 times x is 25x. 25 times negative 3 is going to give me negative 75. And now change signs. And it's so easy, like, to forget to do that change sign stuff. That's why I'm putting it in different colors and stuff. Like I really want it to stand out to you. All right, because we need this term to zero out. The only way we can do that is by changing those signs on both of them. All right, so what am I left with for my remainder?
80.
80. All right, so my final answer on this is going to be 3x squared plus 9x plus 25 plus 80 over what?
X minus 3.
Yeah, whatever that divisor is, right, what you're dividing by. And that's how you leave it. Okay, so it's just going to take a little bit of practice, I think, just remembering that long division, but I know you guys can do that. So let's see, how's this?